So I repassed out these notes. I expanded them and added this to the end of it for total mechanical energy. I also went back and reworded. So if you haven't figured it out in this class, I teach by example, meaning that I teach and explain how things are done, and then we work on several problems together. If you aren't paying attention, or if you aren't working with it with me, chances are you don't know how to do it. So let's go over this together. So on the front page is a list of equations for you to solve. So if you know mass and velocity, you can get kinetic energy. If you know kinetic energy and velocity, you can get mass. If you know kinetic energy and mass, you can get velocity. This first formula page is going to be given on your test. So if you know mass, acceleration due to gravity, and height, you can get gravitational potential energy. If you know gravitational potential energy and acceleration due to gravity and height, you can get mass. You can plug it in. So the law of conservation of energy states the total energy of an isolated system remains constant. The total energy doesn't change, it can only be transferred. We can exploit this fact to solve very, very complicated problems very easily. Usually, if you didn't have conservation of energy, you would have to figure out the accelerations, the velocities, and figure out how an object is going to move. Conservation of energy, we don't care about what happens to the particle. We just need to know the energies at various points in time. We can solve for gravitational potential energy easy. It's just equal to the mass times 10 times whatever height is at. From this, we can find other information. So instead of having to calculate the forces and acceleration an object undergoes, in order to calculate the path it can take, or will take, we can use conservation of energy to find information at different points in time. Energy can only be transformed into various different forms, but is never lost or destroyed. If we don't include friction, which in this class we're going to ignore all friction, then the total mechanical energy is also conserved. Total mechanical energy is the energy from motion and position alone. So if we have a graph, we can use this problem-solving technique to solve for it. So the first thing you do is create a table like below, where each column represents a different point in time on the graph. So the first line is mass. So G is will usually be 10 meters per second. It's the gravitational acceleration, or acceleration due to gravity. H stands for height. V is for velocity. Ke is for kinetic energy. Pe is potential energy. It's the sum of all potential energies. However, it usually only includes gravitational. And Tme is total mechanical energy, the sum of kinetic and potential energies. Once you create this table, we plug in given mass values. So usually mass is given to you always. We just fill it across the entire row. So we come over here, if the mass of the object is 50 kilograms, we write 50 kilograms, 50 kilograms, 50 kilograms across the entire row, because the mass usually doesn't change. Then we plug in a gravitational acceleration for the entire row. That's because the acceleration due to gravity never changes over time. Technically, the higher up you go, it does change. So if you had a roller coaster that started on the beach and went up to Mount Everest, the gravity at Mount Everest would be very, very slightly smaller, but approximately about the same. So unless you have a roller coaster that goes into outer space, G is going to be approximately 10 in all cases. So we can go ahead and then put it in 10, 10, 10 across the entire row. Next, we plug in any other given variables from the graph, such as height. What height was it at point A? What height was it at point B? What height was it at point C? And so on. If it gives you any speeds or velocities, we plug it in. So maybe it says at point B, it's going 11 meters per second. So at point B, we plug in 11 meters per second. If it says the object starts at rest means not moving. So we put in, if it starts at point A and it's at rest, we plug in 0 meters per second. If total mechanical energy is given, or as soon as you figure it out, it's constant. Total mechanical energy doesn't change. John, wake up. Pay attention. Lift your head up. So, also if it says it comes to a stop, coming to a stop also means 0 meters per second is your speed. We're also going to assume that the lowest point on the graph is 0 meters. So I might tell you it starts at 10 meters and then comes all the way down to the ground. I might not put at the very bottom of 0, but we can assume the very bottom of the graph is 0. And now we begin filling out the other bits of information. So if we know M, G, and H, we can solve for potential energy. That is, this is technically gravitational potential energy, but it's mass times G times H. If the height is 0, then potential energy is going to be 0. So if it's on the bottom, then potential energy is 0 too. If you know mass and velocity, you can solve for kinetic energy. Kinetic energy is 1/2 times mass times velocity squared. If your velocity is 0, then your kinetic energy is also 0. At rest also means kinetic energy is 0 too. If you know kinetic energy and potential energy, total mechanical energy is just the sum of both of them. You will also not going to be giving you this. This is all going to be learned by practice. So if you know kinetic energy and potential energy, total mechanical energy is the sum of both of them. Total mechanical energy in the absence of friction is constant. So the moment you solve for TME, total mechanical energy, you write it across the entire row. If you know total mechanical energy in one of these, you can solve for the other. So if you know kinetic energy in TME, then potential energy is just total minus kinetic. If you know potential and total, kinetic is total minus potential. And if you know kinetic energy and mass, you can solve for velocity using the equation on the formula page. So if you know kinetic energy and mass, velocity is equal to the square root of 2 times kinetic energy divided by mass. And if you know potential energy, mass, and gravitational acceleration, you can solve for height. Height is potential energy divided by mass times acceleration due to gravity. You repeat all these steps until the table is filled. Occasionally, you'll have to refer to the formula page to solve for special variables such as mass and acceleration if they aren't given, or if they're stated in the problem that's unknown. Note, in almost all cases, M, G, and total mechanical energy is constant, meaning that once you know mass, write it across the entire row. G is usually 10, so write that across the entire row. Once you solve for total mechanical energy, it's constant, write it across the entire row. I don't think in any cases do I tell you that the mass or acceleration or total mechanical energy changes, so it'll be over the entire row. Nicole, would you mind passing that out? You'll need a calculator if you haven't grabbed one. Again, the best way to learn this is by trying to do it yourself. It's practice that actually makes you learn this. So you should be working along with me. So the problem says, assume the total mass of the roller coaster in person is 250 kilograms, and that the acceleration due to gravity is 10 meters per second squared. So what should we do with these two numbers? Which boxes will they go into? Yes. So 250 kilograms doesn't change. Note on the quiz, each box was worth 2 points. So if you just put 250 kilograms across the entire row, you wouldn't have made a 0. I actually gave it to you on the quiz, M and G. So G is the acceleration due to gravity. We can do the same thing. 10 meters per second squared across the entire row. That doesn't change. So at point A, the mass of the person on the roller coaster is still 250 kilograms. At B, the mass doesn't change, so it's still 250 kilograms. At point C, again, it doesn't change. And at point D, it doesn't change. So these values are constant. And acceleration due to gravity doesn't change unless you're going from Earth's surface to outer space. Now we plug in known heights. H stands for height. So we look at A. What's the height at point A? 10 meters. At point B, 0. So if it touches the bottom of the graph, we assume that's 0. At C is what? 3. And at H max, or D, is unknown. We don't know it, so we leave it blank. So what about the velocity at point A? 2 meters per second. And we don't know about B and C. I will tell you this is a new problem. So let's imagine this. You're on a roller coaster going down a hill. So let's look at this. Let's visualize what's happening. It's going down a hill. It's getting faster and faster and faster. At this point right here, this is where you have the fastest speed. Fastest speed at bottom. We're going to then go up a small hill and slow down. Then we're going to go back down. What's eventually going to happen as you start going up this big hill? You're going to stop, right? So if you stop, what is your speed? 0 meters per second. So eventually you're going to go up a giant big hill, but you're not going to make it over the hill. You're going to come to a stop. So again, when given a graph, you have to think about it. You have to visualize what's going on. So at this point, you come to a stop at some highest speed height. So this is what it means by H max. The highest point before you stop. I like doing, so if you look at my little suggestions, I like doing first MGH and solving for potential energy. So if you know mg and h, you can solve by potential energy by multiplying together. So if you know mass, acceleration due to gravity, and height, these multiplied together give you potential energy. So potential energy would be equal to 250 kilograms times 10 meters per second squared times 10 meters. So that is for potential energy, 2,500 joules. And energy is measured in joules. We can do the same thing here. 250 times 10 times 0. So 250 times 10 times 0 is 0 joules. Doing it here. 250 times 10 times 3. So 7,500 joules. Here we don't know height. We can't solve for potential energy yet. Now let's see if we can solve for velocity. Velocity, or kinetic energy. Let's see if we can solve for kinetic energy. Kinetic energy is equal to 1/2 times mass times velocity squared. So if we know mass and we know velocity, we can solve for kinetic energy. So this would be 1/2 times 250 times 2 squared. So what does that equal? So kinetic energy is equal to 1/2 mass times velocity squared. The mass is 250. The velocity is 2. This should be 500. 500 joules. That's what you do. You take 1/2. So a half of 250 is 25. A half of 250. 2 squared is 4. 4 times 120 is 500. So again, it's 1/2 times mass times velocity squared. So 1/2 times the mass times velocity squared. Anytime you know kinetic energy and potential energy, total mechanical energy is equal to kinetic energy plus potential energy. So we know that this total is going to be just these two added together. So what is 25,000? What is 25,000 times plus 500? All right. This is constant, right? So we can write anything that doesn't change for all the other ones. So 25,500 across the other ones. So what should we do next? Get kinetic energy. So what is kinetic energy equal to? Other way. Total minus PE. So 25,500 minus 0. 25,500 minus 7,500. So kinetic energy again is equal to that'd be 18,000. Kinetic energy here. Can we solve for kinetic energy here? So we have two formulas for kinetic energy. kinetic energy is equal to total mechanical energy minus PE, or kinetic energy is equal to 1/2 mv squared. Do we know what the mass and velocity is? Was that a yes sir or no sir? We know mass, so that would be equal to 1/2 times 250 times velocity is 0 squared. That's 0. Yes, so if you're at a stop, kinetic energy is 0. Again, kinetic energy is the energy of motion. If you aren't moving, you have no energy of motion. Yes. So now we have almost the entire table filled out. For the last problems, for these problems here, you're going to have to refer to your formula. So for velocity is equal to the square root of 2 times kinetic energy divided by mass. So velocity is equal to 2 times the kinetic energy, which is 2,500 divided by the mass of 250. So plug that into the calculator and make sure you can type that in correctly. Also, make sure you type it in as a decimal. Maybe type in 250 with a period behind it so that it gives you a decimal. So 14.282857, and this is velocity, so it's meters per second. So did everyone get this? If you aren't getting it, I'll come help. You need to know how to type this into the calculator. Yes. You can if you want. Work ahead. Alright, so I said put a decimal after the 250. You can also, let me see it. Yeah, just put a decimal after the 250 and press enter. Yes. So if you're getting an answer of 2 times the square root of 51, I believe it was, you just need to go in and put a decimal point after a number, and that'll give you the decimal number. So for example, if you come up and do 2 times, again my calculator is different than y'all, and you get 2 times the square root of 50, come over here and just put a decimal after a random number, and it'll give you a decimal number. But did everyone get 14.28 something something something? Oh, the subscript on this? So subscripts describe the variable. So this stands for gravitational potential energy. Just like VI, the I stands for initial velocity. So this stands for gravitational. Nothing. This is treated as one thing. So PEG is literally just one variable. Just like VI was one variable. Yes, we can treat it just like regular potential energy. So coming over here for C, we can solve for the velocity the same way. Velocity is equal to 2 times the kinetic energy, 18,000, divided by the mass of 250. If you put that in the calculator, you get 12 meters per second. So I'll give you a little bit to work on D, the height. Put your mask on. So did everyone get 12 meters per second? You didn't? You need me to come check? That's 1800. What number is that? Is that the number I have written? So what's the equation for height? So mass times g. So height is equal to potential energy divided by mass times. This only works if the potential energy is only gravity. In this case, we don't have any rubber bands anywhere. So unless I have a spring or a rubber band, potential energy in this problem is just gravitational. Yes. Everyone get an answer? What'd y'all get? 102. Are you sure you're reading it right? Oh, did you include the G? So, using y'all's calculator. So the potential energy is 25500. If it's on the denominator, make sure you put parentheses. So that'd be 250 times 10. And give you 10.2. Nah, 102. What did you do wrong? Yeah, 25, not 250. Oh yeah, I'm excited. I have a doe and 2 small fawns that come up to my back porch. I can open the door, I can wave at them. I can also open one of my bedroom's windows and hunt from it. In the nice heat, while watching TV, I'll kick back with a rifle pointed outward on the bed, watching TV. I'm excited because the buck now comes up too. No. So the height is 10.2 meters. Again, the pictures don't match up correctly. The pictures are not the scale. It actually, there is no possible. So you're right. This is 10, and this looks way more than 10.2. If you were to try to guess and say that this is halfway or a quarter, you're not going to get anywhere close to being correct. I make up all these numbers, and the numbers don't quite nor correspond to the picture. Like, for example, this 250 kilogram mass is not the correct mass. I changed it up. So these pictures will be slightly off. You can't use the picture. You have to rely on the math. So let's now do this one. So we have a skater. He's moving at quite a high speed. He's coming up a ramp. So let's suppose we want to figure out what's the max height a skater can get on a ramp before sliding back down. So what are the first thing we're going to do? Right, 80 or 60 kilograms. His mass doesn't change. We can also, in this class, assume that we're on Earth, unless otherwise stated. Unless I say that we're on the moon or some other planet, we can assume that 10 meters per second. So unless the problem says otherwise, we're going to assume we're on Earth. Earth is probably one of the better planets. I think we won the best universe pageant. Earth was one of the best in the universe. The last time I checked the votes, we won by a landslide. So what's the height at point 1? 0, because it's at the bottom. Height at 2? 1 meter. Alright, are we given any velocities? First one is 8 meters per second. Or can we derive any other velocities from the picture? Are you sure? I can. So it says here the skater reaches his max height. You reach your max height because you have stopped. You stopped right here. So because you're stopped, you can assume your speed is 0. So if we see a height of 0, that means that our potential energy is what? 0 joules. And if we see a velocity of 0 meters per second, kinetic energy is going to be 0. Any of y'all play Sudoku? Y'all play Sudoku? This is kind of like a Sudoku, except for instead of looking to see how many mats, we're applying equations to the table. You get points for any square you finish. That's how I grade these. Is usually every square is worth 1 or 2 points. So even putting the 60 kilograms is way better than not doing turning it in blank. So now let's see if we can solve for other stuff. Again, from this point on, it's random how you do it. Once you write the given stuff from the graph, everything else is kind of random. So I always begin with potential energies. Because if I see an M, a G, and an H, I can multiply them all together. 60 times 10 times 1. So potential energy is equal to 60 times 10 times 1. That's 600. And this is our potential energy. So 600 joules. I don't have a height here, so I can't solve for potential. Now let's see if we can solve for kinetic. So kinetic is equal to 1/2 times mass times velocity. That's 1/2 times 60 times 8 squared. And that is 1,920. Now what's the next step? Total is equal to sum of these. So we add these together. So add them. That is 1,920 joules. And what next? So the moment you get this number, I highly recommend the moment you get this number, fill the rest of it out before doing anything else. The moment you get total, because it's constant, fill the rest of the table out. So kinetic energy would be equal to 1920 minus 600. You mean if you paid attention on Thursday and worked with me? Alright. And potential energy is equal to total mechanical energy minus kinetic energy. So this minus that. Now we have two spaces left. So velocity is equal to the square root of 2 times kinetic energy divided by mass. So that would be square root of 2 times 1320 divided by the mass of 60. Again, don't use square roots. So when you type it in, to get rid of that square root, you type in, okay, there it is. Square root of 2 times 1320 divided by 60.0. So you can do 60.0, and that gives you that value. And then lastly, the height. So again, looking at our list of equations. So this is the main equation, by the way, guys. If we were in physics, I would only give you these two equations, and you have algebra for the rest. Because we don't use algebra for in this class, I did the algebra for you guys. So height is equal to potential energy divided by m times g. So that would be the potential energy is 1920 divided by the mass of 60 times 10. Make sure you include parentheses around that. So 60 times 10. And that's 3.2. And this is meters. Yes. You only got 3 minutes to the bell. Never mind. You got 4 minutes. 5 minutes. Yeah. So again, this is easy, right? If you took notes and looked at your formula sheet, this is easy. However, if you don't try working with me in class, if you don't try doing this yourself, you won't be able to learn it. This is something that requires practice on. That's the reason why I work on examples with you in class. You should be working and trying to figure this out using a calculator on your own. Because that is really the only way, or I think y'all could learn this, is by practicing. If you aren't paying attention, if you aren't taking notes with me, you won't get this. Do not lose this. We will continue it tomorrow. As the last two problems are somewhat tricky. It's not that, well, the last one's kind of hard. Because it asks for something else. So here's the code word for the day. Again, there's the code word.